Welcome back, everyone. Today, we will examine the behavior of a new relation that will end up being an exponential function. Exponential functions are commonly used in many fields, including finance, biology, physics, and engineering. They have a unique property that makes them stand out from other types of functions. We will explore the graphs of such functions and determine some of their basic features. So let's get started and dive into the world of exponential functions. Suppose that we have the relation y equals b to the x. I am referring to it as a relation because at this point, I don't know if the graph of this relation is a function. That is, if the graph passes the vertical line test. In fact, a goal of this lesson is to figure this out. But now I want you to observe this expression right here and see what is peculiar about it. How is the structure of the expression similar or different from previous relations that you have studied in the past? That's what I want you to think right now. Before we answer the previous question about similarities or differences with previous relations, let us look at B, at the base B. For example, in this case, B could equal 2, so I could have 2 to the x, or b could equal 3. I could write 3 to the x. Or b could be equal to 1/2, so I can have y equals 1/2 to the x. But can b be -2 or -3? Can b be negative? This is another unknown at the moment, and we will have to come back to this a bit later on. At this particular moment, we don't have enough information. Here are a few known relations from the past. For example, this one right here is linear, this is quadratic, this is a cubic relation. I think that by now we are all pretty familiar with most of these relations. And we're also pretty familiar with their graphs. I know that we have studied quite extensively lines and quadratics, parabolas. Now let us compare these relations with the new ones right here. Notice that the relations on the left, this one right here, all have the variable x as the base and the exponent as the fixed number. So in this case, the exponent is 1, but the base is x. Here, the exponent is fixed, is 2, but the base is x. Whereas right here, we have something in reverse. I want you to notice that here, it is the exponent that is the variable, yet the base is the fixed number. In this case, the base is 2. Same thing over here. The exponent is the variable, and the base is the fixed number. Now, let us start investigating what the graph of such relations will look like. We will go back to basics, and we will create a table of values. I have chosen already these particular x values, and we're going to use the expression right here to compute the y values for each of these pre-selected x values. And then we're going to go, we will transition to the xy plane, and we'll try to see what the graph will look like. Here we have y equals 2 to the x. And we're going to start with -3. That means that we're going to have 2 to the -3, which is equal to 1 over 2 to the third, which is equal to 1 over 8. So 1 over 8 here. Now with x equals -2. 2 to the -2 equals 1 over 2 squared, which is equal to 1 over 4. Then x equals -1. 2 to the -1 equals to 1/2. Then when x equals 0, we're going to have 2 to the 0, which is equal to 1. And then when x is equal to 1, we're just going to trivially have 2. When x is equal to 2, we're going to have 2 squared, which is equal to 4. And then continuing here, when x is 3, we will have 2 to the third, and 2 to the third is equal to 8. So that's what we have. Now, in this case, I want you to notice the table. This is the table that we just filled out a few seconds ago, and these are the y values that we computed. Then here on the right, I went ahead and I plotted each of the points. So this point right here, this one here, this one here, they are all plotted over here. And we can kind of already see a potential shape for this graph. Now in this case over here, you can see the same points that we just had, but now we see a smooth graph passing through those points right here. And I think that now it is evident that this is the shape of the relation y equals 2 to the x. And I can even do better now. I can stop calling it a relation. Now I see that it passes the vertical line test. I mean, look, if I start drawing vertical lines, the vertical lines intersect with the graph are at only one point, these points right here. So then this particular graph is the graph of a function. So now I know that y equals 2 to the x is a function. Now, in this case, we have the second relation. Now here the base is 1/2. It's a number between 0 and 1. Before we had 2 to the x. 2 was bigger than 1. But now we're going to do something slightly different. So now we have 1 divided by 2. So 1/2 to the x. And we want to see exactly what the graph of such a relation will look like. But before we go to that, I want you to remember these special properties of powers, especially powers dealing with fractions. So please remember that a over b to the negative power of n to the negative n is equal to the reciprocal of a over b, in this case b over a to the positive n. So again, I'm going to be using this property of powers in order to figure out the y values that corresponds to each of these x values. Let's go ahead and do that. So again, we are going to be using this relation right here. So starting with -3. Y equals 1/2 to the -3. That's going to be equal to 2 over 1 to the third. And this is now using this relation right here. And this is going to be equal to 2 to the third, which is 8. So I'm going to put 8 here on the left. Then we're going to have 1 over 2 to the -2. That's going to be equal to 2 over 1 to the +2. Again, using this fact. And then 2 squared is equal to 4. So that's going to be 4. Then y equals 1/2 to the -1. That will be equal to 2 over 1 to the 1, which is just 2. Then when x is 0, 1/2 to the 0, this is always equals to 1. Then we're going to have 1/2 to the 1, this is just 1/2. And then 1/2 squared, remember this is like having 1/2 times 1/2, that will give us 1/4 right here. Let's continue with the last one. we're going to have y equals 1/2 to the third, which is going to be equal to 1/2 times 2 times 2. So 1/8. And now the table is complete. In this case, you see the same table with the same y values that we just computed. Then each of these is a point on the grid, and you can see those points right here. And we can already pretty much determine the shape of this graph. Here you see the same points that I had before, and now the smooth curve is passing through those points. And we can see clearly now the shape. Notice that the shape, it's very similar to the shape of the previous function, y equals 2 to the x, very similar, but there's a subtle difference. They're not exactly identical. Lots of similarities, but there's still a difference. All right, everybody. I hope that you found this lesson helpful. This is not the end of this particular topic. This is just the introduction, the first part of 3 videos that will develop the idea of exponential functions for that. Now we're going to move on to part 2, and I will make sure to link part 2 in the description box below.